Okay, everybody. I would like to welcome our first presentation, our first lecture for today. We've got the steam-powered telegraphy guys here, Jens Ohlig, Skyty, and Sebastian Felke. And as Tim mentioned before, we're going back into history, but not merely 5 months to the Chaos Communication Camp, but rather a century to the age of steam-powered telex as a primary means of long-distance communication. Well, and you have it. Enjoy the show, and you enjoy the lecture. Thank you.
Welcome indeed. We have traveled far from a faraway region of the Prussian Empire in Cologne to come to the capital of the Kingdom of Prussia here in Berlin to introduce you to our latest invention, which is steam-powered telegraphy. That means an apparatus capable of transmitting signals through the wire powered by a steam engine. Next to me, on my very right, the young master Sebastian, steam engineer, the Martefooled engineering werewolf, who will enlighten the honorable ladies and gentlemen of the audience on the principles of steam engineering. And to my right, the Honorable Mr. Skyty, an expert in the field of signals and encoding of the arcane of transmitting signals over the wire using a telegraphy apparatus. We are not from the CCC, we are rather from the SSS, the Scientific Steam Society, and we would like to present you our invention. It has caused us some trouble and grief during the last days. This is why we stand before you today with eyes that resemble those of the panda bear of China in the Far East. And we had more than one catastrophe in setting up this apparatus, but at least we have something to teach you and we have something to present you. Our steam engine powered telegraphy engine is at the very core powered by a steam engine which was designed and constructed in many hard nights of work by Sebastian. And he will give you a short overview of the principles of steam engineering that we used for this.
Good evening, ladies and gentlemen. I may now tell you something about the principles of steam engines, or why it is not desirable to build a steam engine at all. As you may have noticed, this whole apparatus is not actually steam-powered, it is telegraphy-powered, it's vice versa. But I come to that later on. Can we have the camera? Oh yeah, the camera. Maybe I'll just go into the front so I can show you some specialties of this whole apparatus. Well, when mankind discovered the powers of steam and heating water and the pressure and everything, they actually invented the pressure cooker. It's very cool because they led them to fast food, or whatever. Yeah. Well, so some guys, 150 years ago, called Papin and Bolden. They, no, it's not Bolden, sorry. It's, oh yes, I should have known that. It's Papin and Newcomen, sorry. They invented the first steam engine at all. And then they weren't so good economics. So there were James Watt and Matthew Boulton who started to reinvent the whole thing and sold them. And this was the beginning of steam engineering at all. So the most difficult part of this is to get all the parts, because, well, just go to the do-it-yourself store and say, oh, I want to build a steam engine. Yes, yeah, you want to build a steam engine? You're nuts. Yes, and I am nuts, yeah, I really am. So, I'll show you some of the parts, and especially this one here. This was our first attempt of the boiler, which is a fire extinguisher. So I called at this do-it-yourself store and said, "Oh yeah, I need a fire extinguisher. Do you have one?" "Yes, we have one." "Yeah, actually, I don't really need it to extinguish a fire, right? And I do not want to build a bomb." "No." Yeah, he was about to call the cops, I guess. So, this whole thing is a double action steam engine, which means the steam comes from both sides of this piston here, which doubles the power of the whole thing. There are little ones, single action steam engines, like this tiny piece here. Well, yeah. It's just coming from one side, the steam. And it was really difficult to build it because I hadn't a proper workshop nor proper tools. I used the kitchen of the club room in Cologne for welding and soldering and everything. And we did had some victims, yes. A 19-inch high-resolution screen with metal sparkles on it now, imprinted in this glass screen. Well, and 2 fire extinguishers and a table. Yeah. So, but no human beings got hurt, so it's okay. So, let's go to the boiler. Let's continue at the boiler. This one is made of iron, so you may get rust problems. So we inserted high concentrated phosphoric acid to get it rust resistant, because it combines with the iron and then it gets iron phosphate, which is very rust resistant. The first attempt was Coca-Cola. Sorry. Yeah, got a total mess. So it got some valves, like this security valve, which goes off every pressure above 10 bars. So it's safe, and we got a manometer. It's, yeah. But I come to that later, because this is all theory, yeah. And we go to the practice later on. So it was supposed to work at pressures at below 10 bar, and well, it didn't work out actually. And so let's come to the practice of it. This thing bursted 3 days before the Congress. Yeah, we just filled water in and boiled it up and everything and heated it up, and like This was on 3 bars, and then kapow! Just broke, and there was hot water everywhere. Yeah. So I managed to get a pressure cooker, this one here, and it got everything. It's approved by the TUV, by the German TUV, so it's safe. Yeah. And some guy came to me yesterday and he said, yeah, I built a steam engine, yeah, and I used a pressure cooker too. So it's just, I think it's normal, so actually. So let's go to the piping. Most people use copper pipes. Those people can solder, those people can weld copper. I can't. I noticed that while building it. And it was very difficult to put these copper pipes in shape. So I used garden hoses. Yeah, they're temperature resistant and they go back in shape, and that's really cool. I put some pipe clips on it, so this will do. Yeah. Yeah. Well, so let's go to the mechanical transfer, which steam does nothing without a piston. This one here, it's a piston from the industry, from Festo, and well, yes, it looks very, very cool and shiny and everything, and it's stainless steel, which is very important if you build a steam engine because it's run by water. So. Yeah, this is the main piston, and then we got this steering piston here. Let me tell you something about the steering piston, because as I said, it's a double-action steam engine, and we have to alternate the steam pressure between those 2 sides. And this is done by the steering piston. I call it this way. I don't know if it's really called steering piston or anything, whatever. Yeah, you see it, if I put it this, the steam goes up here, push the piston into this direction, and when it comes here, it goes to the other hole, and so this would run very fast, actually, because it's working in resonance. Then the flywheel and the crank axle. This is the flywheel. Maybe you can show it with your fancy cam, the crank axle. So it works this, and yeah. You see it? It's going to. This is this is where the dead point is, because there's the pressure, the same pressure in both sides of the piston. And it goes back, shoves the steering piston this way, and then that point again, and there you are. So this is how it should work. And the rim is just a leather tape, which also broke before the Congress. So we get just a wire, and we were very afraid that the leather tape would come here and flip it into, and it was ripped in pieces, literally, because it was so fast, and flap, then it came into this into the telex, and we were afraid it broke, but it didn't. So operating this engine, let's come to the worst part of this whole thing. It didn't work at all. As you may have noticed, I told you at the beginning, it is telegraphy powered. And well, we called this whole engine the BTNSE, which stands for, in abbreviation tradition, for Better Than Nothing Steam Engine. And Brie, who's working for the Makers magazine, he came to me, yeah, I have a steam engine. You have a steam engine? Yes, I have a steam engine. Why didn't you tell it much more earlier? Well, and this is a little one here, and we run it with a gas and everything, and it's very tiny, and I call this one here, it's the BFSE, it's the Breeze Fantastic Steam Engine. Actually, that's everything. Because and after all those trial and errors, I still do not surrender before the mysteries of a good running steam engine, of a fast running steam engine, and I hope I can fix it for the next year maybe. And then you may see a very good running steam engine. Yeah, that's it.
One thing we learned from this project is it's important to fail with style. And in theory, it all works. It's just the practice that is bothering us at the moment. However, the steam engine is just one component of our apparatus, the other component being a telex machine. Telex, for those who may not know it, is a standard for telegraphic transmission of characters over lines. We usually ask people, when do you think was the first global telecommunication network established that gave people the opportunity to send instant messages and email? And people globally, around the whole world. And people usually say something like, I would say in the 1980s, but if you ask me like that, maybe a bit earlier, like in the 1970s. They are all completely wrong, of course. It was in the 1930s that the telex telecommunication network was established. And it was the first global telegraphic network for transmitting characters online with automatic dialing. It is nothing like the telephone network we have today. It is a completely different network. To our surprise, it is still somewhat operational, and we try to get a telex connection for this Congress, but it seems like Deutsche Telekom is not taking any new customers. Which is somewhat understandable, because they will be switching off the service January 1st, 2008. Last chance to see. What you see here is the agony of the global telex network that gave rise to news agencies just as Reuters and AP that rose in the 1930s and could transmit through field reporters the news of the world in real time. And of course, there was already ASCII porn on it. We have studied the telex network after acquiring such an ancient machine. Actually, it's a model from the 1950s or 1960s, we are not really sure, but we ripped off all the unpleasant plastic parts to give it a more steampunkish style. And this telex machine can actually transmit characters up to a lightning fast speed of 50 BPS or 50 baud. And on the further mysteries of the encoding that is done with telex, the Honorable Mr. Skyty will enlighten you.
Light speed indeed. Well, if you think that 50 BPS is not very fast, then I got news for you. Many of you came here maybe by car and used something that is called Navstar, or more globally, the GPS system. And now guess about the transmission speed of the ephemeris and almanac data that comes down from the satellite to your GPS receiver. Still 50 BPS. Now actually, switching from BPS to baud, a different unit, a unit that tells us how often per second a signal can switch its state. So this thing is also working with 50 baud. And for every one of you who knows somehow the hacker prayer, knows about the beauty of the board. And the unit baud is related to a guy called Baudot, who also created some kind of encoding, a 5-bit encoding, that has somehow later been adopted to a different standard, CCITT alphabet number 2. And this is exactly the coding that our telex machine is using. It is a 5-bit code. 5-bit. Okay. How many characters? 2 in power of 5, 32. Now let's wait. I got 26 characters in the Latin alphabet, and I got 10 numbers. That's almost something about 36. 32, 36, doesn't match. So what they actually did, they said, okay, let's split it up. Let's build a table with 2 columns. One for letters and one for figures. So we have 26 letters on this side and 10 figures on this side, and lots of symbols like dash, minus, column, and so on. 26 left and right. And then we have to have a shift character that can shift between the figures and the letters. So the 27th line in these 2 columns is letter shift and figure shift. And then we need these nasty things like carriage return, line feed, white space. And then we're somehow at 31. Okay, so 2 columns and filled up to 31, so there's one left, 32. What about row number 32? Now guess what is row number 32 for? It's not the bell. The bell is actually in the figure, the terminal bell, yeah, which is actually a bell here, makes ding. No, it's locales. So who needs UTF-8 if you have like 2 characters for locales? I'm somehow waiting for someone to come up with maybe 2 very nice Klingon characters. So 5-bit. If the camera, can you come here, please? Now the thing is, this machine is totally mechanic, right? It's totally mechanic. There is no electronic part in it. There are just 2 electric parts in it, which is just the conducting coil and the switch, which is right here. That's it. And then here we have like 5 bars. Here are 5 bars. Here are 5 bars, which actually represent the bits. And now the question, okay, now today, actually we have computers, lightning fast computers, so 50 baud somehow sucks, we want to use it, but okay, how to use it with the computer? Because this thing, if it's on, you heard it before when we just printed the message, it ticks, right? Tick, 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 tick. So we thought about, okay, let's build a Heiser ticker. And here's the claim. Actually, Yule says, no, we want to build an RSS reader. So 1930 somehow meets 2007. And now the question is, okay, here is a mechanical engine. How can we connect it to a computer? And we thought, okay, what about the electrics? Okay, this thing is using a constant current interface, 40 milliampere. And now if you think about, okay, we have like 5 bits. And the thing is using also start bits and stop bits. That somehow sounds familiar. So what about RS-232? Oh yes, your generic UART in your computer can do this if you still have one in your computer. So we thought, okay, all we have to do now is just somehow make it work together on an electric way. So here we have a constant current interface, and for the RS-232 we have a voltage interface where like 0 volts is silence and plus 12 volts is the start bit. For the telex machine, it's actually the other way around, right? The 40 milliamperes is the silence and 0 is the start bit. So actually, we built something like this. It's a breadboard, and it's nothing that you can't build with any junior electronics kit. So all you have to know is like, how does an optocoupler work? How does a transistor work? And how to create a constant current source. Kirchhoff will be your friend. So anybody in the 8th grade will be able to do this. And anybody in university will be maybe able to calculate how it's going on, but actually you don't need to do it. It's rather simple. And then again, okay, now we have a RS-232 interface, but hey, actually we want to do RSS, so this is somehow an internet thing. And so we thought, okay, well, let's build a daemon. A daemon is nice, so it can do TCP/IP, and everybody today does TCP/IP, even Macs and stuff like that do TCP/IP. I say that because Joel is a Mac user, and he wanted to do the RSS reader and the Jabber client. And here, at this point, I'll head back to Joel, because after the daemon was finished, actually you can take a look at it. It's RSS2 TTY on SourceForge. It's a project, so they will find the schemes, the electrical schemes, and you will find the source code. Happy exploiting. It's a network daemon. And about the demonstration of the RSS reader, Joel.
Yeah, just before we try to print out an actual RSS feed on this ancient machine, I would like to mention something. Actually, we were supposed to be 4 people on stage today. My very dear friend Ingo von Schwitters, inventor and adventurer extraordinaire. He could not be with us because some fiendish flu virus hindered him from appearing on this very stage. But yeah, he was really the driving force behind this, and actually this was really a group effort with so many skills involved, steam engineering, soldering stuff, network daemon, and then Web 2.0 shit as well. So we wouldn't be presenting this today if it was not for the group effort we did at the Chaos Computer Club Cologne C4. And now we will try to print out the RSS feed from this very event. It should work.
So what is happening now? We connected actually our RSS reader to the telex. Okay, it's beta, okay.
It's Web 2.0, it's beta. There's still room for improvement. Okay, thank you. This was our presentation, and we are absolutely eager to hear your questions on our project. Questions? Any questions? Yeah. I think there should be someone coming to you with a microphone, right? No? Okay.
Testing. Oh, hello. Do
Hello.
you have any problems doing hardware maintenance on the telex machine itself? I've tried maintaining one, and it was springs kept popping out of the machine.
We had all kind of interesting problems. One interesting task is to get the paper for the punch tapes and the telex paper. Sometimes eBay is your friend, sometimes it isn't. And you will have to go to shops that will sell old stocks of paper for telex machines, so that is one problem. But what is really amazing about this machine is it was literally taken from the attic of one of our club members, dusted off, and went like a charm. So this technology was still in use in the 1980s by the German military because it was safe and secure, and it would even work in the case of a nuclear attack because there's so little electronics in it. In fact, there's none. It's all purely mechanical, and even after an EMP goes off, this machine will still work and will transmit your messages. And at the moment, we're thinking about maybe setting up an ultra-secure network between hackerspaces using telex machines, because the government talks about monitoring email, monitoring internet. They never talk about monitoring telex.
So we were also thinking about the revision, which is connecting telex to Enigma, connecting telex to one-time pads. And talking about reliability, actually, we went to the Telecommunications Museum of Telekom in Aachen. Our dearest friend Michael Kollian, he prepared the trip. And there was a guy who gave me a book. It was somehow from 1964. And when I read that book, I think at about page 30, one of those data carries here, which is 5-bit punchline on paper, fell out of it. And I thought, ooh, a punchline. Okay, let's take a look at what it says. So I switched on my telex, put it in, and it told me the name of the guy who owned the book and a date, and the date was 1967. And I thought, wow, okay, can you please try to find me a data carrier that will still work after 40 years? Any more questions?
So basically, this is indestructible technology, really. Any more questions?
Did anybody bring a telex machine? I think I saw someone bringing one in, but maybe there are more. Oh, so there is one in the lab, says Shorty. Any more questions? Oh, there's a question.
Did you ever look at going through the message systems that would be on the net if you connect through the telex net? So at the moment you connect directly at the machine level. Did you look at using whatever the modulation, demodulation over the telex net would be?
We have a book on that. Yeah, actually we have a book on that, and we also saw it in the Telecommunication Museum. So they have these, what's in German, Vermittlung, whatever this is in German, in English. And actually they showed us. It's a totally different network. It's possible to automatically dial. And in former times there was between countries. There was a manual set over between countries. Later on this was done electronically. In the way that when you were typing on your telex, you had to set a certain code, like ZZD something, and then the country, and then again some suffix, and then a number, and would automatically go out to that country. And they even had funny things like semi-automatic setovers, where they simply had a telex machine in a country and had it print on these data carriers here, on the punch lines, and just inserted this one into another. Right.
More questions?
If the steam powering would have worked, what part of the machine would have been powered by it? Would it be working without electricity at all, or how would it work?
Yes, more or less so.
Yes. Well, as it was said, most of this teletype is mechanical. If we maybe attached a generator to the coil, it would work. Yes, just driven by a steam engine. No more from the no more 230 volt.
So actually all you really need is a 40 milliampere constant current source. So this can be a battery or a generator, whatever. This is the only thing, but you need it for data transmission, not for driving the engine. For driving the engine, you can also use like an ASL and do it by yourself. And that would work if you're synchronizing to 50 hertz.
Oh, and the other thing we wouldn't have if we hadn't electricity on this is this lamp. Yeah, but we could do without that. But basically, you can run the thing without any electricity. That's why we thought about powering it by steam. So there's a question over there.
Well, you dressed up so well. May you come in front of your construction so that we can take some beautiful photos?
So the question was, where do we get our costumes? What costumes? Well, you know nerds, usually we stand up in the morning and we just take on the pile that is lying in front of the bed, right?
Okay, if that was it, then we really want to thank you. We were here at the Congress. And of course, we will continue to work on our construction. And who knows? Who knows?
Yeah, and sorry for the steam thing. I just released the steam from the pressure cooker, just so you will see it will explode or something.
Okay. So thank you.